we wanted to know what was out there, which studies have been done on reusability, what type of studies these are, and what the lessons learned are. Basically, we wanted to make a literature review, what is known, not only in the public scientific literature, but also within the companies that operate those systems, and see if that is similar knowledge or different knowledge. Obviously, we all are in favor of a waste-free, climate-neutral society. And the real question is, how do we get there? And that's not so easy. We have made a very complex society with a lot of flows of materials through our society. And how do we get the materials back in the most efficient way? It's very simple to say, well, if you have an object and you let it remain an object, it will always be better. But if you look for more on a holistic vision of the whole society, you will see that there are so many transport movements that it's not always so simple. And it really is dependent on your local situation, what type of looping strategy works the best for you. It's too simple to say, let's recycle everything or let's reuse everything. That doesn't work. We have to look to the local context. You will see that the predominant literature can be split in two halves. One is on logistical planning, and there's a second volume of literature on the potential environmental benefits of reuse systems. There's those environmental benefit studies, roughly the half of the literature, have what-if scenarios. What if we have 2 loops? What if we have 3 loops? What if we have 4 loops, etc.? And calculate the environmental benefits based on those assumptions. I came across 2 studies with actual data, actually describing how much loops on average were performed in an existing reuse system. And that means that we have a very unbalanced literature, but it gives a misformed interpretation of the reality. There is insufficient data on the current reuse systems. There is a huge discrepancy between what's written in the public scientific literature and the knowledge of incumbents that operate those reuse systems. And that's an issue. If you look in detail, this hierarchy is a simplification of reality, obviously. Again, when you properly organize your reuse system with minimum transport distance, with minimum cleaning efforts, etc., and with maximum amount of loops, it can be great. And it can have lower impacts. But this is a combination of if. And if one of these ifs is not met, then we have another situation. And then recycling could be a better option than reuse. So reuse is never always better than recycling. It depends on your local context and what you can organize. There is some consensus that roughly the benefits start at 10 loops. You should have more than 10 loops before the benefits really become clear and pronounced. If you have lesser than that, there is often not an environmental benefit. When we speak about transport distance, we mean the distance from the locality to the retailer to the consumer, so the forward motion and the backward mode. That total transport distance should not exceed preferably 150 kilometers. If you then compare it to efficient cleaning equipment that usually operates at 50,000 packages per hour, you can imagine that you need a lot of consumption within that radius to make that cleaning operation efficient. And yes, of course, you can work with less efficient equipment. You can do it, but then also your CO2 emissions will rise. So it's a difficult balance between transport and cleaning efficiency that confines the result to more highly populated regions. So if you're in a lower populated region, you will need to cluster. You will need to have a lot of packages in the same format. So multiple food products, for instance, in the same packaging format that can be exchanged. That is not so easy. Try to put a cheese in a meat packages and vice versa. It's not so simple to get the volumes you would optimally want to get an efficient reuse system. There are a lot of meat, fish, cheese and vegetable products that are sold on the modified atmospheres to give them shelf life. All these packages are hermetically closed with a modified atmosphere inside. How to make a hermetically closed reusable system? That's a large share of the market. We might talk about a quarter or more of the complete food market. So if we could tackle those type of questions, we could really make progress. But I cannot see it at the moment, how we can make a reclosable, hermetically sealed, reusable package. That's still a challenge. Consumers are notoriously difficult in the sense that you will have always a small group of highly enthusiastic people that will change their habits and lifestyle and fully accommodate to the new system. And you have a large middle group that will only adapt in time, and you have a small group that will never adapt at all. Getting the middle group motivated to participate and making room in their own houses to keep the packages that they have finished separate and to bring them back to the shops, for instance, that's a habit change. That's something in your daily routine which you might not even think about that you have to change. And those are the changes that are most difficult to make. You will have for every product, you have other packaging requirements and you have regional context that varies. So I can imagine that in urban centers, large cities, Berlin, Paris, London, those type of large cities, we can start with reuse systems. But then they should be operated well, and all the companies and consumers and governments should be aligned to achieve it. If we don't do that, we'll never get it done. It's not a quick fix, simple solution. It needs large investments and it needs a lot of reallocation of land, of trucks, of materials, and people think too simple about it. It's really a major change in our consumption system. Targets should be on the things that we really want to achieve. It's like, for instance, less CO2 emissions. That should be a target. And then depending on the local context, it could be a reuse system or a recycling system that offers us the lowest CO2 emissions. My worry is really that we'll get an explosion of all kinds of systems without any integration between them, and the end result is worse than we have now.